Hello guys, and welcome back to the DevOps Guy channel. Today we are going to learn about Amazon Web Services. We are going to create and launch an EC2 instance. We will then see how to attach another disk to our EC2 instance. We will also attach an Elastic IP to it, and we will check the connectivity using the Elastic IP. Finally, we will create and manage a snapshot of this EC2 instance. Let's get started. Amazon Web Services provide a lot of cloud-based resources. EC2, or as we call it, Elastic Cloud Compute, is one of them. EC2 service is the virtual machine offering by the Amazon Cloud. EC2 machines are also called EC2 instances. Let's create one. Before creating the EC2 instance, we will first have to set up some basic set of resources for networking. All those resources are grouped as virtual private cloud or the VPC service. Let's check the VPC service first. As you can see, I am on the VPC dashboard and you can see a default VPC already connected for you. This is done for all new accounts in Amazon Web Services. You will get a default VPC. And let's now check the subnets. As you can see, this is the subnet dashboard and we have 3 subnet by default created in the default VPC. You need subnets inside the VPC, which are basically the subdivision of the VPC network or the VPC CIDR. Okay, and after creating subnet, we also need a route table in order to send the packets across the subnets and outside the internet. If you see in this case with the default VPC, we also have a route table, a default route table. Let's move on to the EC2 dashboard. And as you see, let's click on running instances. There are no running instances right now. We will have to launch a new instance. The first step is to select an AMI. An AMI is nothing but a base image that is seeded by the provider of that image, in this case Canonical, because we are selecting Ubuntu 18.04 image. These images contains the base OS, which will be used to boot up your virtual machine. Let's move on to the next screen, the instance selection page. Here you can see there are a combination of different instances with CPU, memory, disk, and network performance. These instances also cost you different prices based on what instance you select. We will be selecting T2 Micro for our session, which has got one virtual CPU, 1 GB of memory, and low to moderate network performance. Let's move on to the next screen, wherein you configure the instance details. Here you can see the number of instances, which is 1. Then the network, which is basically the VPC name. We already have a default VPC. And then the subnet configuration. So one EC2 instance can be launched only in one subnet. So we will leave the subnet preference to Amazon. And next is the auto assign public IP, which will be enabled by default. So we will get a public IP with our instance. And let's leave all other settings at their default value. Okay, let's move on to the storage page. Here you can see this root volume /dev/SDA is by default there. This is based out of this snapshot. As you can see, this snapshot is the AMI that you selected on the first page, the Ubuntu 18.04, and you can see the size by default is 8 GB, which was created during the AMI creation process. We will increase it to 10 now. This is the volume type. We will select the GP2 type. There are 3 different types of volumes based on the workload, and we will select the GP2. Then there is the IOPS that are provided with this volume type, throughput, and then delete and termination checkbox. If this is checked, then your volume will be deleted when your instance is deleted. If it is not, you will have to go and manually delete the volume. This is the encryption for your EBS volume, which is to be set. We will not encrypt it right now. Let's move on to the next page. Here you can add tags to your instance and other resources like EBS. These tags help us identify the instance separately. So you can add tag like name, which will apply to the name of the instance. So let's put the name as test hyphen instance. Now there are the checkboxes for instances and volumes. These will propagate the tags to instances and to the volumes if the respective boxes are checked. Let's add another tag as environment. Let's put it as development, and let's add another tag as billing, and we will put the value as testing. Let's move on to the security groups. So security groups are the firewall given by Amazon Cloud to protect your resources inside the VPC. Security groups have filter on inbound and outbound traffic. You can add specific IPs or your specific IP or a CIDR to enable inbound and outbound communication. We will try to create a new security group for our EC2 instance, although a default security group is also available. Let's create one. We will name it as test-instance. Let's fill in the description. And now we will add some rules. If you see, a default rule for SSH is already added, and the source for this is custom right now. We will make it to our IP so that only we can SSH into it. There are other options like anywhere, but that will render your instance being attacked from anywhere in the world. Let's put my IP and let's put a description to it. SSH access from my computer, and for now we will go with this rule only. Let's move on to the next review screen. On the review screen you can see the settings that you have selected in the previous pages. As you can see, we have selected Ubuntu Server 1804 image, and the instance type is T2 micro. This is the security group with the rules. Only SSH is allowed, and these are the instance details. This is the storage disk of 10 GB, and those are the tags. Let's try to launch our instance. When we click on launch, we will have to select key pair, which will be used to SSH into the instance. We will have to create a new key pair because right now we don't have any key pair associated with this account. This key pair is basically a SSH public private key pair. The private key will be given to you and the public will be added to the default user of the AMI. Let's create a pair named test-instance and let's download this key pair. So let's save the key pair, and now we will launch the instance using this key pair. Okay, so the instance is launched now. We can check the launch log. As you can see, it has created the security group and then added the inbound rules. Let's check the EC2 dashboard now. So this is our EC2 dashboard. As you can see, the instance is running now, and it is running in the availability zone AP South 1B. Quick note on availability zones. These are basically the separate data centers in the same region, and these are called as availability zones in AWS terminology. And if you see, the instance has got an instance ID with it and the name tag that we have given to it, test instance. The status check is still initializing. So these status checks are basically checks by Amazon on their virtual machines. If you can see, there are two status checks, system status and instance status. Unless this is green, you will not be able to access your instance or log into your instance. Next is the monitoring tab here. So AWS provides you few of the instance or your VM matrix here, like CPU, network, disk. You can view them in AWS CloudWatch service as well. And these metrics are provided with every instance that you create. Let's move on to the tags. You can see the tags that we had added are present here. You can add more tags to the instance from this screen. Now, if you see, there is a public IP given to our instance along with a public DNS name as well. So if you want to access this instance, anything hosted on this instance from outside the world, you will have to use this public IP or the public DNS name unless you map it to a public DNS yourself. Now let's check the security group. If you click on it, it will show you the inbound and outbound rules. Inbound is port 22 from my IP and outbound is all to everywhere. Now the status check is reporting as passed. If you see 2x2 checks passed, let's try to SSH to our instance. Let's take the public IP of our instance because we are trying to connect from the internet, and let's try to SSH into it using the key file that was downloaded, test-instant.pem, and let's use the user Ubuntu at our IP. The reason we are using user Ubuntu is because by default on AWS Cloud, the Ubuntu AMIs has the default user Ubuntu set to be login. For other AMIs like Amazon based Linux, we have EC2 user as the user. So we are going to use the default user and try to log in now. Say yes to it, and you see there is an error which says unprotected private key file. So we need to set the minimal permissions on our PEM file. Let's check the permissions. If you see, it is 644. It has to be usually 400 or 600. So let's modify it to 400. And now if you see the permissions are correct, let's try to log in now. And we are inside the instance now. Let's check the private IP here. If you see the private IP here and on the instance page, it will be the same. That means we are in the same instance. Let's check the host name, which is not set and defaults to IP- the private IP of the instance. Let's check the version of Ubuntu. We selected 1804 and this is Ubuntu 1804 LTS, which is correct. So this is how you can launch an instance in AWS Cloud. Let's try to install some application and try to access it from our public IP. Let's do an apt-get update first. Let's install Apache 2 now. We will be accessing this web server from our public IP. Let's try to check the status of Apache 2 now. So Apache is up and running. Let's try to curl on the localhost to get the default page of our Apache 2 server, and we get the default page. That means it is working. Let's try to get this web page from outside our instance using the public IP of the instance. Let's curl using the public IP now. And as you can see, there is no reply from this host. This is because if you go back to the AWS console and check the security groups, we don't have port 80 allowed. So now we are going to allow port 80 so that we can access our instance from outside. Go to the security groups page and go into the inbound rules and add a new rule. You can use custom TCP or built-in HTTP rule. Both are okay. we will use the built-in HTTP. You see TCP/80 is already selected. We will put it as my IP in the inbound IP, and let's add a description too. So as you can see, the security group acts as a firewall here, an external firewall to your resources. Let's try to do the curl again, and this time we got the page. So that's how important role the security group plays for any of the AWS resources. Now let's try to get the page using our web browser, and you see the default Apache 2 pages displayed. Let's try to use the public DNS given by AWS for our instance. And you see this also points to the same instance. So unless you have any DNS name set to access your instance, you can also use the provided DNS names by AWS to get to your instance. Now let's explore more about the EC2 console. If you click on actions, you can see there is instance state. You can stop, reboot, or terminate your instance. And let's go to instance settings. As you can see, there are different kind of activities that you can do. If you go onto image, you can create a backup or a snapshot of this running EC2 instance. We will be covering that in a bit. And if you click on networking, you can add more security groups, you can change the IP addresses, and this is the CloudWatch monitoring options. So now if you click on one of the graphs, let's click on the CPU utilization graph, and you see these are, it will show you some of the metrics, like the CPU utilization was 25% there. And similarly, you can browse other graphs. Status checks are all green. Let's check the disk attached to this instance. As you can see, this is an EBS volume, and if you open it in a console, this is the EBS volume page, wherein you can see the EBS volume is attached to the instance. It has got a volume ID, the tags are carried forward, it's a GP2 type volume, the size is 10 GB, and if you see the volume is running in the same availability zone as that of our instance. You also get CloudWatch monitoring matrix for your volume as well, and it has also got status checks as like the instance, and you see the tags are carried forward. What are EBS volumes? EBS stand for Elastic Block Storage. So this is a type of network mounted disk that you can attach to your EC2 instances. There is another type of EC2 disk which is called instance store, which is basically the disk attached to the same rack as that your EC2 instance is running. Those are local disks as opposed to the EBS volumes, which are network mounted. So when you restart or stop your instance, any data that is saved on your instance store gets removed, because essentially the VM moves from one node or one physical machine to another physical machine, but the data on your EBS volume is persisted even when you stop or reboot your instance. Let's try to stop our instance. Go to instance state and click on stop, and we will see that our data will not be lost because we are using EBS volume as our root disk and not the instance store. So instance is stopped now, and you can see the public IP is gone now. This public IP was a dynamic one, and hence at every stop and start of our EC2 instance, this IP will not be retained and will be lost on stoppage. When you start the instance, you will be given a new dynamic public IP. However, your private IP will always be retained unless you terminate the instance. And let's check the volume now. If you see, the volume is still in use. This is our root volume, and this is not destroyed when we stop our instance. Let's try to start the instance again. and check whether our changes are still there or not. As you can see here, our instance is up now and it is given a new dynamic public IP. The old IP will not be accessible to this instance and it will either point to some other resource or it will be unassigned. Let's try to curl on both the old and the new IPs. Let's try the older one first. And if you see, there is no response from this IP because this is either reassigned to some other resource or it is unused. Let's try to check with the new IP given to us. And you see the default Apache web server page is displayed here. So the public IP is quite dynamic in nature. If you reboot or stop your instance, it will be released and a new dynamic IP will be assigned to your instance. Also, as you can see, our disk was persisted and it was neither reset nor destroyed when we started our instance. What if we want to use a permanent IP which doesn't change based on instance reboot or stop start? That's where we use Elastic IP. Elastic IP is basically a permanent IP which can be shuffled between resources inside your AWS account. Let's go on to the Elastic IP console. Here you can see the list of Elastic IPs will be displayed. We don't have any Elastic IP. Let's go and create one. Here you have the option of getting an Elastic IP from Amazon pool of IPv4 addresses, or you can bring in your IP as well. For this tutorial, we will be sticking to Amazon IPs. Let's allocate an Elastic IP. As you can see, this is the public IPv4 address. And now this IP can also be tagged along with your resources. Now we will try to allocate this Elastic IP to our instance. Go to associate Elastic IP address. You can either associate it to the instance or to the network interface. So if you see the network interface which is attached to the instance, you can attach the IP to this interface itself or to the running instance. We will try for the instance, and in the instance dialog box, let's choose our instance because we only have one instance running. Let's pick that up and associate. Now you see the Elastic IP associated to this instance ID. The instance ID will also show up here along with the private IP address. Let's try to refresh our EC2 instance page and you can see the private IP is changed to Elastic IP and Elastic IP is showing the Elastic IP that was allocated to this instance. Now if you stop or restart this instance, this IP will be preserved and will be attached to this instance. Let's try to check the IP. This is the older IP and you see there is no response because it has been unallocated. Let's try our Elastic IP now. And you see the default web page is available here. So this Elastic IP is attached to our instance. Let's try to stop the instance now and check whether this IP is deallocated or still remains attached to our instance. So the instance is stopped now and you can see the Elastic IP is still attached to the instance. Let's start our instance back. Okay, now let's see how to add a disk to our EC2 instance. Let's toggle to the instance first. List the block devices and you see the root device is XVDA and the partition XVDA1 is mounted on / as the root file system. Let's get back to the console. Let's try to create a new volume from the EBS Volume console. The volume type will be GP2 and the size, let's select a 10 GB volume. Now coming on to the availability zone, you have to select the same AZ as that of the instance. Only then you will be able to connect to this disk. So our instance is running in AP South 1B. We will select the same AZ, and we can also select a snapshot from which to restore this volume to, but as of now we don't have any snapshot. We can also select the tags here. So I will add a tag as test instance. And click on create. You see the volume is created now. And the state of the volume is available. We will have to attach it to our EC2 instance in order to make it use from the instance. Let's try to attach the volume now, and we will select the instance ID, test instance, and here is the device where we want our disk to be mounted to. So the way this device mount point work is your /dev/sdf is mounted as /dev/xvdf or whatever character that you have chosen. That's how you will access the drive on your EC2 instance. Let's try to attach it. Okay, the disk is being attached, and now let's get back to our EC2 instance, and you can see, let's do a lsblk, and the new disk is available as xvdf. Now let's format the disk and attach it to one of the mount points. Let's format it with ext4fs. Let's create a directory called /backup. That's where we will mount our disk. Let's mount it now. xvdf to backup. And if you see, the disk is mounted to /backup now. So you go inside backup directory, there will be only lost and found. So that's how you can attach a disk to one of the running EC2 instances. The important thing to remember here is to select the same availability zone as that of your EC2 instance. Otherwise, you will not be able to attach the disk to your EC2 instance. Let's try to create a snapshot of our EC2 instance. We call it AMI or AMI image in AWS World. Let's go to Actions, Image, and click on Create Image. Here you will be asked the image name. Let's put as test-instance. Put in the description as well. And then this no reboot button. If this box is checked, then the instance will not be rebooted. Otherwise, before taking the snapshot, this instance will be rebooted. We will keep the no reboot selected. Now let's get to the disk. Here you can add or remove as many disks that are attached to your EC2 instance as you want, except the root disk, which is required. We will not select the additional disk. Let's click on Create Image, and the request has been received. Let's go to the AMI console where you can see your snapshots. This is the AMI console. As you can see, our snapshot is in pending state. It is being created right now. It will take some time to get created. So essentially, this snapshot is a live or a hot backup of your running EC2 instance. You can either try to stop it and then take a cold snapshot, or you can do it while running as we did in this case. Our snapshot is completed now and is in the status available. Now we can use this snapshot to launch another EC2 instance or to restore our EC2 instance at a point in time where the snapshot was taken. Let's terminate the EC2 instance that we created now. Let's go back to the EC2 instance console and let's try to terminate. And here it will show up the elastic IPs and the EBS volumes. So this elastic IP, if you don't select this box, it will be available in your account. You can reuse this with any other EC2 instance. But if you select this elastic IP will be released from your account. It might be given to some other account, or it might get into the Amazon pool of addresses. The EBS volumes which do not have delete on termination checkbox selected while creating them will also not get terminated, and you will have to terminate them manually. Let's click on terminate, and you see the instance is shutting down right now. It will take some time to shut this down and then terminate the resources. So our instance is shut down now. Let's check the volumes. As you can see, the volume that we created after the instance is still existing because it didn't have delete on termination flag set. We will try to delete it manually now. Let's delete this volume. So the volume is in deleting state now. It will be deleted. Let's go on to the Elastic IP console, and you can see our Elastic IP is still existing because we didn't check the release this Elastic IP checkbox while terminating our EC2 instance. Guys, Elastic IP comes free with every EC2 instance. So one Elastic IP per EC2 instance is free and covers the cost in the EC2 instance cost. But if there is no EC2 instance and you have an Elastic IP address which is not yet associated with it, it will cost you on an hourly basis. So let's release the Elastic IP as well. Let's check the security group console now. As you can see, the security groups are not deleted along with the instance. So you can relaunch new instances using the same security group, or you can attach them to other instances. This completes our session on AWS EC2. So guys, what did we learn from this session? We learned that VPC is required to launch an EC2 instance and that the default VPC is created by Amazon. We also created and launched an EC2 instance. We also added an Elastic IP to the instance created, which processed through reboots and stop start of the instance. We then added another EBS volume to our EC2 instance. And we created a snapshot of the EC2 instance, which is also called the AMI. And finally, we stopped and terminated our EC2 instance.